So I'm going to try and show you how to use R to do a simple two-sample t-test. So here I'm using some data on fish aerators I had. The data are stored in a matrix called my.data. Hit return. So here's the raw data. So basically I just want to see if the mean oxygen level is different whether I have one aerator or no aerators. So I have two groups, no, 0 aerators, 1 aerator. I'm going to compare the mean oxygen between the two at the simple two-sample t-test. So the first thing we always want to do is simple descriptive stats, mean, standard deviation, sample size for each group. I'm not going to mess with that right now. I do want to check the assumptions of the t-test, the first of which is that each of these groups is normally distributed, and I'm going to test that with a Shapiro-Wilk. So you'll forgive me, I gotta check my crib notes here. Okay, so I'm going to go by number aerators, comma, oops, I need the dependent variable first. So first I'm going to go DO ppm, which you'll see that's my dependent variable, that's oxygen level. The next thing is number aerators, which you'll see here, that's my grouping variable, that's my independent variable. And then what do I want to do on here? I want to do Shapiro.test, which is the Shapiro-Wilk test for normality. So this command says do the Shapiro-Wilk test, but do it on oxygen levels, which is a dependent variable, but do it separately for each value in number of aerators. That's what the by statement does. So do it by number aerators. So it's going to run it for each of these. Hit return, and here you see a common R error message. I did this on purpose so that I could show you this error message. It's saying error da 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 da, object not found. R is telling us it can't find this variable, but we know it's there. We see it right here in the data set. The problem is we didn't tell it where to look for those variables. We didn't tell it which data set to use. Now there's a couple different ways of doing this. The easiest is to just attach that data set. If we go attach my.data, all that does is tell R, hey, whenever I ask you to look for a variable, look for that variable in the data set named my.data. Now I'm going to rerun this by statement instead of retyping. Another cool thing about R is just hit the up arrow to get back to earlier commands. I hit the up arrow once, well, that's the command I just typed. I hit it a second time, and you see here's the command I already typed, so instead of having to retype it, now I can just hit return, and you see it works now after I attached that data set. And so number aerators, p-value is greater than 0.05, so we fail to reject the null for Shapiro-Wilk. The null is that the data are normal, so we can say that for one aerator the data are normal, and for 0 aerators we also fail to reject the null. So one of our assumptions is fulfilled, or our assumption here is fulfilled, that each group comes from a normal population. Our other assumption of the two-sample t-test is that each of these groups has equal variance. However, we can make an adjustment in which we don't need that assumption, and that R does that adjustment automatically, so we'll forget about the assumption of equality of variance, and we will get to the box plots. We always want to plot our data before we run any tests. So let me go back to my cheat sheet here. Box plot. Yes. Okay. So we're going to go box plot, and we're going to go the dependent variable, which is dissolved oxygen in parts per million, and then we're going to use the tilde, and the tilde is always a character that you use when you're trying to make a statistical model. We use these in ANOVA, sometimes linear regression. Anyway, we're going to plot the oxygen by our other variable, which is number aerators. Hit return, and over here to the right, as you can just see part of it, let me drag it over here. You see R opens up the graphics window, and here it made a nice box plot. 1 aerator, 0 aerators. We can see that the heavy line, that's the mean, and you can see that the mean oxygen is quite a bit higher if you turn an aerator on, but we're not sure if it's statistically significant. You've got the whiskers out here showing, box plot shows the spread of these. So that's always a good way to visualize your data. Okay, so now on to the actual t-test. We've checked our assumptions, we looked at the data. Again, we need descriptive stats, but we're not going to run those today. You can do those in Excel or R if you want. Cheat sheet, t.test. Got it. Okay. So to run a t-test in R is pretty simple. t.test. And we're going to use the same syntax we just used in box plot. Dissolved oxygen, tilde, number aerators, close parentheses. So this says run a t-test in which you use oxygen as the dependent variable. Compare mean oxygen levels between the groups you find in number of aerators. Hit return, and here's our Welch 2-sample t-test. The Welch part of this, that is the adjustment for lack of variance. So by not assuming equal variance, we have to use this Welch adjustment, which works very well. T-test is very robust. So here's our data. Here's the value of T. So there's your test stat. Here's your degrees of freedom. You see it's a weird value. Degrees of freedom is usually a whole number. That's the Welch part of this. Welch adjusts the degrees of freedom to so that we don't have to worry about that one assumption. Here's our p-value, and you see it's much less than 0.05, so we can reject the null. So we can say that these two groups are significantly different. And since we saw in the box plot that 1 aerator, the mean oxygen was higher, we can say 1 aerator has significantly higher oxygen than no aerators. And here you can see if we reject the null, the alternative is the true differences mean is not equal to 0. This is a two-tailed t-test. If we want to do a one-tailed, we can, but we don't want to do that here. And here's the mean value of oxygen with 1 aerator, and here's the mean value with 0 aerators. And so these two numbers are considered statistically significant. Whether or not they're biologically significant is a different story. And that's it. That's a 2-sample t-test using R.